Imagine asking an AI a simple question. You type a few words, hit enter, and boom. Within seconds, you've got your answer. It feels completely weightless, doesn't it? There's no factory, no exhaust, no giant roaring machine sitting right there in front of you. It's just a screen. Welcome to this explainer. Let's just dive right in, because we're gonna look at the part most people never actually see. Behind that tiny weightless response is a massive physical machine. We're talking powerful computers, staggering amounts of electricity, intense cooling systems, networks, and highly specialized chips. And as AI gets more powerful, this hidden infrastructure is basically becoming one of the biggest technology stories on the planet. So what actually happens behind your screen when you use AI? And why are giant data centers, power grids, and even water suddenly becoming the absolute center of the AI race? Section 1. The invisible machine. At the very core of this entire revolution are data centers. And honestly, the contrast here is kind of wild. If you look at the outside, many of these places looked surprisingly boring, just ordinary massive industrial buildings. But inside, it's a completely different world. They contain row after row of computer servers. And these aren't your everyday desktop computers sitting on a desk. AI relies heavily on highly specialized processors built to crunch an enormous number of calculations. When you link thousands of these processors together, that is exactly how you train and operate these incredibly powerful AI models. Section 2. The heat problem. All of that incredible processing power brings us to an immediate, very physical consequence. It's basically a massive chain reaction. Step 1, the processors churn through enormous calculations. Step 2, because of that intense work, this high-performance equipment generates a massive amount of heat. I mean, think about your laptop for a second. When you run a heavy program, you hear the fans kick into overdrive and the bottom gets hot, right? Well, multiply that problem across an entire warehouse filled with top-tier computing equipment. That heat literally has to go somewhere. Which brings us to step 3. To keep from melting down, these facilities use sophisticated air cooling systems, or even advanced liquid-based cooling technologies designed specifically to pull heat away from densely packed hardware. The whole goal is simple: keep the machines at safe operating temperatures so they can work 24/7. Section 3. The energy question. But hey, cooling is just one piece of the puzzle. The computers themselves need staggering amounts of electricity just to turn on. This is where the AI story stops being just about tech and becomes a massive energy story. Take a look at these dates, 2026 and 2027. In the United States, electricity demand is projected to hit all-time new records during these years. Now, to be fair, AI isn't the only reason for this growth, but data centers and other forms of electrification are directly contributing to this massive increase. The rapid expansion of AI is absolutely becoming a central part of the entire electricity demand conversation. And the sheer scale of this challenge brings up a pretty stark, difficult question we really have to ask ourselves. If AI keeps expanding like this, where is all that electricity actually going to come from? Well, there's no single silver bullet here. Companies, governments, and energy providers, they're basically scrambling for an all-of-the-above approach to fuel the AI race. They're looking at building more traditional power plants, rapidly expanding renewable energy, reviving nuclear power, and leaning on natural gas, or honestly, using a massive combination of all of them. But you know, there's another resource people are increasingly talking about: water. The total environmental footprint of AI goes way beyond just the power grid. Because many of these data centers need those advanced cooling systems we just talked about, water becomes a huge part of the process. Depending on the facility, we're talking enough water to fill multiple Olympic-sized swimming pools. And as this expansion pushes toward 2026, local communities are starting to actively push back. They're asking hard questions about how these new facilities are going to affect their local water supplies, their electricity bills, the noise levels, and their infrastructure. Section 4. Scale and benefits. The AI revolution has created this incredibly unique situation where the technology feels entirely digital, but the infrastructure behind it is heavily physical. Just look at the stack in reality. We are talking about sprawling, huge buildings, enormous power equipment, complex cooling systems, thousands of miles of fiber optic networks, specialized chips, and massive transmission lines. It's literally an overwhelming mountain of physical hardware all working together just to support that seemingly weightless text on your screen. But we've got to look at the other side of this story too, which balances everything out perfectly on this table. These data centers aren't just being built to waste resources for no reason. Look at the column on the right, the digital benefit. Millions of people and businesses increasingly depend on these services every single day. AI helps researchers analyze immense oceans of information. It assists software developers. It supports major global businesses, drives complex scientific research, and helps create entirely new products. We genuinely rely heavily on what this massive physical machine is capable of doing. Section 5, Behind the Screen. So that brings us to our final chapter, zooming all the way out to the global ecosystem. Because ultimately, the challenge right now isn't simply deciding whether AI is good or bad. The bigger, more pressing question is right here. Can the infrastructure behind AI grow efficiently and responsibly? The future of AI isn't just going to be decided by who builds the smartest model. It really depends on who can provide the electricity, cool the massive machines, manufacture the chips, and connect it all together without creating unsustainable pressure on our local resources. So the next time you ask an AI a question, take a second to remember what you're not seeing. Behind that instant, simple answer could be an enormous, sprawling chain of machines, energy systems, cooling tech, networks, and people all working together. As this final quote says, AI may feel like something that exists strictly inside your screen, but behind the screen, there is an entire physical world powering it. And honestly, that hidden world could soon become just as important as the AI itself. Thanks so much for joining me for this explainer, and remember to keep looking behind the screen.